All right, this is going to be interactive, so this is just not me doing it, guys. So what we're going to do on a typical rack course now, the compressors are never this high. So a little bit of benefit, we've already gone through and broke all the bolts for you, and Randy has already drained all the oil, so give a round of applause for Randy, because that's a real pain in the butt. I've seen it where it's poured out afterwards. Typically, here's the method to the madness. I'll start off with the heads. So depending on how many I have, we're going to go through and we're going to take the heads off, look at the valve plate, take the valve plate off, and when you take the valve plate off, you got to be real careful about the gasket, because sometimes, and you know, if I don't have a hammer, I'll technically just use the head to kind of hit it. That's all you got to do. You'll hit that valve plate. When it's coming off, you want to feel as if you're actually tearing that gasket or not, because some of the slug that I talked about earlier, remember, it could be a liquid that could slug it, could also be oil from Bubba, but sometimes the slug may not just be busting that reed, it could be just a busted or broke through the gasket. That's one thing I'm talking about. When you take that valve plate off, if it's actually, when you take it off and some of the gasket's missing, you got to make sure you thought ahead of time, did you rip it off or was it gone to begin with? So the first thing we're going to do is we're going to take the head off this one. So we got a 3D, and it's just the bolts along the outside. So if you got an impact wrench, this does not take very long. Of course, if you're pumping the system down and you're gonna take the heads off, or you're gonna take it out anyway, I want you guys to take the extra 15 minutes, 20 minutes to take these things apart. Because what you're gonna find out is gonna be invaluable, because you could actually be troubleshooting this thing incorrectly. Okay, so even though you got the temperatures and the numbers I told you about, inside is always worth a lot more. Do we have a hammer anywhere nearby? So I'm going to take this off. I'm just going, while he's grabbing that, we're going to take the heads off. So I talked about that. So depending on the time, because you'll see a lot of things on top, and this is where you will typically see the overheat situation. Next thing you want to do is take the oil pump side off, not the motor end, because this is a refrigerant cooled compressor. Okay, so the valves are on the, you know, this side and that side. That's a refrigerant cooled compressor. This is like a little K-body you see like in 7-Elevens on little ice cream machines. The valves would be on both sides of the head. That's a air cooled compressor. That's when the liquid refrigerant's even worse. So we may need a bigger one. Okay. Okay, you see how it's kind of cracking a little bit? All right. So let's go and put this over here. Even before I look at the valve plate, what I want to do is look over here. So let me come around this side. I've got oil up here, and sometimes now we've transported these things, so you don't know why the oil is up here. You really shouldn't probably see this much oil, but that's probably just from bouncing around. First thing I'm going to do is I'm going to feel the inside of the cylinders. If there was like the rings got worn out, they would get on top of the pistons, and you think about that piston going up and down, it would look like a cat got in there and was just clawing on the sides. All right, so you know you probably have worn out the ring somehow. So I'm feeling on the inside. I'm also looking on top of the pistons. You know, if there was debris in there, again, remember me talking about the suction filters? I don't want contamination. This is another reason why I don't want that in there. I don't want it on top. So you're looking at it, and this looks pretty clean. I mean, it's actually shiny. I'm not used to seeing this on Florida applications. So next thing I'm gonna do, because I can't really kind of push the pistons yet until I take this off, because we will want to rotate the crank and see if the pistons move. If you look at the valve plate, you're looking at the, again, this is the suction reed on this side. You guys can see on this side. So what's gonna happen is, through the valve plate, this suction reed is going to pull up like this because it's upside down, allow the gas to come into the cylinder, and it's going to push out through the discus basically right here, and that's the discharge. So what I'm looking for here is, first thing is color. But notice it was brown and black, but I just wiped it. Notice it got clean. Okay, so that tells me that it's not actually overheating, it's just the oil has gotten discolored. So big difference. Okay, so maybe just there's contamination in the system, but it's not necessarily overheat. Now if I wipe that and the rings are still brown and black, I'm in the overheat category. So remember, you got 5 things on that PT chart that I gave you. So I'm already kind of, I would, if it was brown and black, I'm looking at the bottom 2, overheating or loss of oil. But now I've got plenty of oil, and the oil I see is actually pretty clean, so it's not loss of oil, and I'm not seeing overheat. So I'm already kind of at this point starting to eliminate 2 out of the 5. That's all I'm doing. It's a process of elimination. So let's go ahead and go to the motor end, because this is where most of the action is usually at. Now most of these are going to be 9/16. Some of the ones on the end are going to be 3/4. So it's really the 2 sockets you basically got to have to get these things apart. So the oil pump, with the exception of the bypass port on that one, may give you a little bit of a fit to get all these bolts off. but it really doesn't take much time. But the idea here is I'm going back to that flood back is why I'm thinking about this one. Because remember, if I got flood back, how much superheat do I have? 0, because that means I got liquid. And if liquid comes into this body, it's going to get picked up by the oil pump. When the oil pump picks it up, it's going to send it down the crankshaft, right? And the further I get away from the oil pump, the less oil I'm going to have. So by the time I get to the motor bearing, which is over here, it's going to be pretty much liquid. So I'm not really lubricating. So that's when you have the motor bearing. Ooh, good catch.
You're a strong boy.
Atta boy. So you're taking this off, and I'm not even looking there yet. And if it got a flashlight, get it ready. I'm going to feel right inside here too. And you're seeing if it's actually worn out. So this is just a feel thing or see, depending on the light situation. And it looks pretty good. I mean, so far this compressor is looking pretty good. So it's sitting over here. You can feel the crankshaft, and there's a spot on here where I can grab, and you can look at the pistons. So are they moving in sequence? Because a lot of times, if it's been a flood back and something actually broke, 2 of them will be moving and 1 won't. And there's no rhyme or reason. Any of the 3 could be broken. It just depends on where the liquid went in. So you're looking to see if all 3 are moving and if it's easy to move. Because if you're doing this in the field, it should be able to move. Now, if these things have been sitting around in a warehouse, this thing could get rusted up, and it's actually pretty tough to break it sometimes when I do these classes. But this is actually pretty good movement. What I would do, anybody got a flashlight on them, by the way? What you're going to do next, you're going to look down at the bottom, and you're doing a couple things. You're doing a couple checks here. So I'm looking at the condition of the oil, and sometimes it's green. Anybody know why it's green?
Shy.
Leak detector, exactly. Okay, I always kind of joke with the guys, it's not mold. It's actually leak detector. So that tells you someone had a leak somewhere. That starts making me think about H2O. All right, so that's something I'd be looking for. I'm also looking for parts, because if something little broke off, you're going to see it in the bottom. So you kind of do a thorough check, and I see nothing except the body and clean oil. Okay, here's the thing on floodback. Let's say this is looking clean. Next out, remember I was telling you guys about shaking hands with the crankshaft? This is what I'm talking about. When I grab this, okay, I can do that. So that's horizontally, it's going to have a little bit of play. Remember what I told you about vertically? How much tolerance?
0.
0. So this is not because I did push-ups last night. If I grab this and I'm able to move this, oh, wait a minute. There's my problem. Now here's what's going to happen. You guys can do this. You're going to grab that, and if you feel any play, now I don't feel or hear any clicking. So this is at that, just barely got over the line. So what's happened is this had liquid refrigerant, 0 superheat, right? Came in, shoots it down the gap, it goes through the crankshaft, gets back here to the motor bearing. I'm repeating myself, but for a reason. And it's going to wear out that bearing, okay, as that crankshaft is rotating through. Eventually, metal shavings come off, and it creates an air gap. That makes this kind of move like this in the motor bearing. That's why I'm able to lift this end of the crankshaft up, okay? I'm making kind of like a lever, which is going to tell me when I take this end off, good chance I'm going to see little pieces of metal. So probably what happened is this guy will leave the, whoever's guilty, anonymous on this tag right here, it probably was a short to ground. I would bet $20 the guy said it was short to ground. He just changed it out thinking it was electrical failure. He has no clue he has a superheat issue right now. Yeah, he's going to meter it and find out that it's an electrical problem. Pull straight up. You see the pistons moving too? Not rotating. Pull straight up.
In and out. Straight up and down.
Oh, I am.
Okay. He did his push-ups last night too. I want you guys to know this because this is a big deal. See how that piston's coming up and down? That should not go up and down at all. So think about this. This guy, short to ground, going to replace the compressor. What's going to happen? He's got liquid coming in. What's going to happen to the next compressor?
Yeah, I felt it.
Is this a cheap compressor? No. This is where I want you to get away from the symptom and get back to the root cause. And I use the analogy of if I go to a doctor and I got a cough, he could give you cough medicine, it gets rid of the cough. But the cough could be caused by a virus or bacteria. Now, if he gives you antibiotics for bacteria, he fixed the bacteria and he fixed the cough. I need you guys to fix the root cause. So in this case, unless you took it apart, you would not know unless you actually checked superheat.
Can I ask a question?
Yeah.
So okay, that's great, taking it apart and checking it. I would love to do that every time. But you're not gonna know nothing until you put that next compressor in and eliminate other things. Okay, this is not happening now.
Right.
So
Okay.
if you didn't know why it broke, when you put the new compressor in, you're gonna take those measurements and make sure it's right.
Exactly.
So that way you say, okay, now there's no problem here.
That's why I give you the numbers, because on a scroll you can't take it apart. But I still need you guys to check the numbers. So a minimum of 20 degrees coming in right here. Okay, the suction valve will be sitting right here. I want 20 degrees. That's a temperature difference, remember? Okay, so when somebody asks you, hey, did you take the superheat? You say yes, it was a number, and I took it at a location.
And it was okay.
Inlet of the compressor, because if you tell me you have 20 degrees of superheat at the evaporator, say you said, yeah, it was cold in that room when I took it, I'm gonna be like, you have 20 degrees inside the evaporator? You got a major problem. That coil is barely doing any refrigeration at all. The gas is flashing off on the first couple passes. 20 degrees is good here and above. Don't get above 40. Okay, above 40, that's when you need to be checking out the discharge temperature. Okay, again, what's that number?
225.
6 inches out, right? And coming in, I want it to be what and below?
65. And
65. So again, on a scroll, if you can't take it apart, you don't have time, but you do have time to put gauges on. Okay, you check those 3 things. That's really the primary thing out of this class is the superheat, return gas, discharge line temperature. Those 3 things you should be able to do every time. And you need to be putting on your paperwork or on that troubleshoot sheet that I have. That's how you do it if you don't have time to actually physically take it apart. But this is the one thing you would not have known though. If you do have time, take the heads off, or at least one of the heads. We're about to do the other one, but check that crank. So since we got that, let me go ahead and take this one off. Let's just happen to see if there's any metal particles. And typically, it's not always. I mean, it may end up looking clean. So what I'd be checking on this side, okay, I don't really feel it, but 2 things. The obvious, you're looking at the windings. You're just making sure that nothing's discolored, okay? Because it could be on its way to overheating. So typically the lamination be first thing, straps the second thing, smokes third thing on motors. But what I'd be doing, in some cases, the motor's kind of embedded inside the body. This style, it's external. But I'm still able to feel down here, and I'm just kind of seeing if I can feel any metal parts. I'm not, but that's why I did the oil pump side first. Sometimes I don't even take this end off, because that already told me what the problem is. Actually, by the time I did the shaking the hands, I'm done troubleshooting. Put it back together. You now know what to go do and what to get. So that one's clean. I'm just going to turn over here and going to ask the question, what do you guys see?
black.
Okay, we don't make valve plates in this color.
Nope.
Okay, maybe a rebuilder does, I don't. In this case, I am going to try to get the valve plate off. So we'll look at the bottom. Actually, that's actually pretty clean compared to the discharge side. But again, same thing. You want to wipe. Oh, look at there. Most of that black's coming off. So the oil was in bad condition, but it's actually it's not baking on there too bad. So I'm borderline on overheat. That's what kind of made me think when I turned it over why it was so shiny, because that's actually wiping off too. So that's actually more the oil than it is actually overheating. Okay, so someone needs to clean up their oil basically. Reeds are in place. The discus puck is in place. Dealing with, by the way, there was a rash of pucks that had problems. Okay, I can put that on the record. If you ever run into valve plates and it's missing the puck, call me. They're older compressors, but there was a problem at the time. So that's one reason to take the valve plates off and take a look on the bottom side. You want to check for that. So now I've got this. Let me go ahead and take the oil pump. So I'm taking the oil pump end off. That feels a little gritty.
Yeah.
Okay. Actually, it is gritty. Okay. So I don't know if that's contamination or metal particles. Okay, that's the question you got to kind of figure out. So kind of the same philosophy. I've got one head off. I'm looking at the top of the pistons. I'm feeling the inside of the cylinder wall. That's smooth. Top is smooth. Okay. So the rings are not worn. They're not contaminants on top. I've eliminated that, which is pretty quick and common. I'm going to get in here, even though I've not taken this head off. I'm still going to rotate and see if these two pistons are actually moving. We got time, we'll take this other one off, but I'm just kind of checking, and it's actually not rotating very smoothly. Like I feel something, it's dragging.
There's something rough. Another picture moving?
Yeah.
Okay, so there's something in there rough.
Yeah, and that's what's got me thinking, like, this is almost like got sand in it, which may be all throughout this thing. So of course, out of the gate, I'm gonna grab this and I'm gonna make sure, well, I've got no play that way. That's weird.
You got a lot of play. Oh.
Can y'all hear the clicking on that one?
You're moving 1/16 of an inch.
Yeah.
Excellent.
Yeah, that's a little bit more than an air gap. Oh, look at here. The oil's green, and I see pieces of metal down on the bottom. See pieces of metal down there? So that's kind of why it's dragging.
Ooh, yeah.
So apparently something's shaved off somewhere. If you really wanted to get into this, we would actually flip it over and take the bottom plate off.
Oh, yeah.
But it's a lot more work to do that, and it's not really necessary. So there's pieces in there. I don't see any major parts missing, but the metal came from somewhere. Again, when I grab this crank and it moved up and down, what's the first thing that comes to mind?
Bearings.
Bearings, and then root cause of the problem? Flood back, which means I had how much superheat? Zero. So the first thing you got to get on to on the next, when you put the next compressor in, is resolving the superheat issue. There's a lot of things on that PT chart I gave you, list a lot of things that are common that cause low or no superheat. So actually I don't need to take that head off. I know what I'm going to see. You can see the exact same thing you saw over here, because that is moving a lot. That's actually probably one of the most I've seen in a long time. And this, by the way, I don't know if you guys know on the, maybe on this side, yeah, the model number, serial number, the serial number, the way it works, the first two digits over here, if you guys see, has a 16 on it, by the way. That's the year it was manufactured, so 2016. The next digit is a alphabet. It says A. A is January, B is February, so forth. So you can kind of tell how old the compressor is. So this one was built January 2016.
2010.
This one's 2010, and I'm not sure we're gonna have a nameplate on it, or we do. 98. I've had them all the way back to the 80s and found no defect found. Just insane what you find here. And you find them where they're only a month old and there's a slug. Yeah, did you scan it, by the way?
Yeah, I did.
Or you just geotagged it? Yeah.
It ain't running at this location.
No, but that's a good point. So you'll see the barcode over here. Again, this is where you want to be scanning the compressors. And if you do the serial number, it should self-populate it in there.
I got a question. So it brings up the compressor multiple times.
Yeah.
So what does all that mean? It brings it up multiple stages.
You'll see the different refrigerant, application, voltage, and hertz.
Yep.
Oh, okay. So you pick on which
So
one
we
you
got
want.
22 down to 404.
Okay, so that's probably
407. Every one of these are different.
Yeah. Because
Okay.
this could be used in multiple applications.
And,
So I need to know the refrigerant.
and the last three digits are building material number, which is 800 is wholesale. It's one we sold to a
It's a replacement.
Yeah.
This
That's a
compressor has
replacement.
died in less than 3 years as a replacement.
Exactly. And
Yeah,
the service-
keep in mind there was an OEM compressor.
original.
This was the second one that went in, or maybe third.
Exactly.
Right.
So when a guy's coming in and say, hey, I've replaced, this is my second, actually we had one at your store one time, I remember a guy, he said he put 4 compressors on the application over at Shan's in 1 week. I think I told, forget, maybe Joe, I said, Joe, take all the credits away from him.
He needs a
I
truck
see.
start compressor.
Yeah, he needs something more than that. All right, let's go ahead and take a look at this one. Here's the third compressor, guys. We're kind of working towards the Florida one now.
That one's been hot.
This one's hot. Okay, it's old, and okay, so all of a sudden something failed, but it's from 1998. Half of you guys were probably still in junior high. If it's overheating, you got to get back to the temperatures of why it's hot and what would cause it. But since it's hot on the top, improvised hammer. Again, I'm kind of, every time I'm looking like I'm a little being cautious, it's because I'm thinking about the gasket. That's just habit. All right, now look at the rings on this one. Again, whoa, okay. Delta read, okay, so these can come off, but that's okay. It gives me a chance to look at both sides of the ring. That's not really wiping off, so this was technically hot. All right, so what temperature would it be inside? Do you guys remember that number?
about 305.
310, 320 is when the oil starts
225 just
breaking
about.
down. Yep. So 225 coming out, 6 inches out because it cools down. It's definitely overheating. I'm thinking at that point,
It's missing there. Is that missing gasket right there? There's nothing here to here.
no, I think it's on there. It's just kind of, it's old. Probably never got
I
changed.
couldn't see it. The green is
Yeah.
wrong.
Now keep in mind, I got all this stuff on the top, which is what you're going to run into the field, so it's realistic, you know. So I kind of look at the pistons. Again, that kind of wipes off a little bit, but not too bad. But I can tell on this one, it's definitely overheating. So you're in those last two categories. And notice on this case, I got some oil that's more like maple syrup, but in some of this, it's real sticky. So I don't know if I'm in the overheat or loss of oil. Remember, those two are kind of in the same bucket. So what we got to do is we got to take this off because we want to see the inside. Notice, even though I'm doing this and I put it back on, they're not gonna be like, hey, the guy hammered it and you're not gonna get warranty. My point of doing that is let you guys know you're able to do that stuff on the warranty. You probably need that hammer.
Still got one in.
Oh,
Slack.
again, I'm feeling in. Now this one's like I feel grit again. There's a lot of it. So I don't know if maybe they got a contamination problem in addition to overheat. Okay, something I would be thinking about. Again, you're finding out all kind of new information by taking these apart. Hey, we got green oil. I don't see any major components, but I see a lot of like metal debris, like metal dust in here. Okay, so definitely, because you think about it, overheating, friction, stuff's gonna be worn off from the heat, and that's probably why I got a lot of metal, because it's shiny down there. If you guys want to take a look, I mean, there's stuff down there that...
It's like shavings?
Yeah, it's not going to reflect if it's sand. So you know you got metal. This kind of reconfirms, again, overheat. If it's overheating, stuff's going to wear out. So the next thing, what are we going to do? We're going to shake hands, right? Okay, and remember, I can do horizontal. I got to always be careful about the direction. Nope. That one's tight. Okay? I don't know if this actually, I mean, they're saying not cooling. It may be because of the wear and tear. Maybe it's got some blow by, because if you actually wear out the rings, that high pressure can go up into the valve plate and then back down. So you're putting high pressure instead of going out as compressed, you actually end up sending high pressure gas back down into the base of the compressor. So you're blowing it by is what we call it, and you've got wear and tear. So it would not be cooling.
But also that would create, you would see that in your high discharge temp as well.
Yeah, it'd be coming down. So you would see a little bit of equalization on the gauges, and then also on oil pressure, the differential would be closing.
Your oil pump too, ain't you?
Oh yeah, absolutely. Yeah.
Did the crankshaft rotate at all? Did it have any rotation?
It didn't, well, you know what? I did not rotate it. Just for sake of time now, if we were to take all of them, we may find something wrong with one of the other pistons. So if you're gonna take it apart, take it all the way apart. But for the teaching purposes, I'm just gonna take the one head off, and you kind of get the point. You're gonna rotate the crankshaft, see if the pistons are moving, because sometimes 4 of these or 5 of these are moving and one's stuck, and if you didn't really get a good look, you didn't know, because a lot of times we'll find that piston's actually stuck in place. It didn't drop down. Until you start rotating, you don't figure it out. So on this one, I definitely would go to overheat. So in that case, I go back to the PT chart that I gave you, or whatever, the Copal Mobile, and find out what would cause it to overheat. But if you were checking it, you probably got high return gas, and you most likely have high discharge line temperature. If there are any kind of electronics, it's going to trip it off. When it gets above 225, doesn't matter if it's semi-hermetic or scroll, after 225, 6 inches out, it's going to trip it out. So something to keep in mind, because you're going to run into a lot more electronics, especially when it comes to guys like a lot of different things are adding to their stuff. You're going to find out that stuff's tripping, and you got to get back to the basics of just refrigeration.
Demand cooling.
Yeah.
Normally it's a 1/4 inch nut. I've seen where they use an adapter or to bush down, and then you put the demand cooling sensor inside. But it doesn't stick in as far. It only sticks in about half the distance.
Okay.
Is that an issue, doing that, as opposed to one that just goes straight in all the way, 1/4 threads versus 3/8?
Yeah, I would question why it's sticking out. At that point, what I would do, because I can't just give you a carte blanche answer on that one, I'd pull up Copal Mobile, get the model number, get the application engineering bulletin on it, and find out exactly how that probe's supposed to be stuck in there.
Right.
So, because every model, because from a medium temp to low temp, it may be different.
Right.
So I can't tell you that every time it's going to be sticking in. What I would do is pull up that model number, pull up the AE bulletin on it, and find out exactly how it's supposed to be done.
It's supposed to be low temp or medium temp, and maybe they
Correct.
mismatched it to the rack.
And it absolutely happens. Voltage, every year I get, whether it could be at the wholesale level or the contractor, but at the end of the day, whoever's putting in, is the buck stops with him. He needs to check the 3 letters. The TFD is the voltage. or actually the last digit on here, the D is actually the voltage. The T and F have to do with the protectors in the motor, but the D is actually telling you what the voltage is. And we do a lot of multi-voltage compressors nowadays just to eliminate how many SKUs we have.
Yeah, TSK is 9 lead.
Yeah, so we'll get guys who have a 3-phase and they put in a PFJ. And then, you know, it's a single phase compressor, they put on 3-phase, we got a problem. We've had it where I've seen we just happen to pick the wrong one. I've actually seen where someone put the wrong one in the box. So at the end of the day, it's still humans involved. But at the end of the day, when you guys are putting them in, again, it's kind of like measure twice, cut once. Make sure the model number matches up with the application. That will save you a lot of heartache, because if you burn up the compressor, it's going to be who said, she said kind of thing of who made the mistake on the compressor. But again, Copeland Mobile, you know, I'm pitching that a lot, but it's going to really save you during the summertime, because trying to call wholesale for questions, they've got 3 people in front of them, they're on the phone, they're trying to find me, where you could just actually find out the information when you're on top of the roof or in an attic or a basement, whatever you're at. You can get that information right on your phone. Or call somebody here at the office and they can send it to you by text. Those bulletins I can send to you by text. So you're going to find out very helpful. So here's what we did, guys. We're not going to tear it all down, but let me kind of summarize. You take the heads off, first thing. You're going to feel the inside of the cylinder walls. You can look at the top of the piston, see if there's any marks. Look at the color of the oil. If it looks black or brown, you're going to wipe it, see if it's actually the oil or if it's baked on. After you've kind of considered that, you're probably going to take the valve plate off. You can see what the color is on the bottom side and double check to see if anything is missing. So if any of these rings, for example, let's say this ring was gone or half of it was gone, what would be my next question?
Where'd it go?
Exactly. Where did it go? I want you guys to be thinking about future problems. It's kind of like strategy. You want to be thinking 2 steps ahead. So if something's missing, where did it go? So after taking the valve plate off and I've looked at the condition of the rings, if everything is good to go there, I'm now going to go to the oil pump side. And for example, on this one, of course, the first thing I'm going to do is look inside, look at the condition of the oil. If it's green, somebody had a leak sometime. So you need to be checking about moisture and then just the condition of the compressor itself. So green is kind of like, hey, somebody had a problem. Look for any kind of metal contaminants in there. And then the last thing we're going to do is what? Shake hands with the crankshaft. Now remember, horizontally, I probably got a little bit of play. This one didn't because it's kind of jammed up. But coming up, okay, we're lucky this one's actually moving a lot where you can see it. I mean, the one-eyed blind guy can see it, but sometimes you can't. Like on this one, that was just enough movement that I could feel it but not hear it. But that's the reason to take that apart. But if that's happening, that tells you had flood back. So that was that first failure mode. Means I have liquid coming back. It ruined the bearing that's furthest away. Okay, so that's when the compressor's running. Remember, flooded starts when it was off. And then slug would be if this one happened to go for even longer, something busted, you would see parts in the bottom. That would be a slug. Or remember I was talking about where it actually broke off the casting. Okay, that's a massive slug. That's a problem. Then overheating is the one we're seeing over here. So that was the number 4 on the failure modes. So overheating is when you're getting the oil above the temperature that it can actually lubricate. And then the last one that we don't have but still need to talk about is the loss of oil. What you would see there is instead of it pouring like maple syrup, it'd be sticky. So I'm actually changing phase. So I always use the analogy of maple syrup to like just gunk is what you would see, and you probably wouldn't see a lot of oil anywhere else. Most importantly, which I thought we probably would run into, but we didn't, but just so you're aware, I gave you 5 failure modes. Remember there were 6. Do we recall what the 6th one is?
No failure found.
Thank you, sir. No defect found. We call them NDS. That's what we're going to run into on the first one because it was looking clean. Could be it wasn't cooling on the tag or broke or whatever, but in essence, the guy had some other symptom. I hope he checked something, and he changed it out, but come to find out, there was nothing wrong with the compressor. Could have been a contactor, capacitor, or whatever. It could have been something else external to the compressor that was causing the problem. So no defect found you've got to be aware of because it's 40% of what we see. So you're going to see it as well. So that covers all 6 failure modes. Any questions? Good information?
Yeah.
All right, so this is stuff that you can use today, right? And most importantly, what did you put on your phone today? Copeland Mobile. There we go. So get Copeland Mobile, get the application engineering bulletin, and you guys will be good to go all throughout summer and probably this weekend because it's going to be hot.
And get the Baker app on your phone.
Yeah, and actually, one thing I'll definitely pitch this about the Baker app, you can pull up the compressors and they show their own inventory. So if you're looking for a specific compressor and it's 3 a.m., pull up the Baker app, and it'll tell you if it's at Leesburg, Gainesville, or at their DC. It'll tell you where it's at. So you're not calling the wrong guy. All right, so it get you ahead of the curve, because you're probably gonna have a couple calls at 3 a.m. So with that, I'll say thank you for your time. We appreciate business. Let's give it up for the guys at Baker.
All right.
Yep. This took quite a bit of work, and guys, we appreciate your business, and definitely be safe out there.